This video demonstrates how to read tree diagrams and use them to calculate basic compound probabilities. A tree diagram is a tool in probability and statistics used to calculate the number of possible outcomes of an event, as well as list those possible outcomes in an organized manner. So in our example here, we have two events, flipping a coin twice. So our possible outcomes are heads, heads. We can get heads, tails. We can get tails, heads, and then we can get tails, tails. Those are our possible outcomes. Now, each branch of the tree diagram represents the probability for the event. So we know flipping a coin, it's a fair coin. It's a 50-50 proposition. You either get heads or you get tails. So the probability of flipping a coin and having it land heads is 1/2 or 50%. Probability of flipping a coin and having it land tails is 1/2 or 50%. So you see our first branch here with that, and then after you flip the coin the first time, you flip it again, and the probability doesn't change. It's still 1/2 chance to get a heads, 1/2 chance to get a tails. And so how do we figure out the compound probabilities here? This is an and. So this is saying probability of flipping a coin and having heads and heads. So what we do is we multiply the probabilities. So 1/2 times 1/2, which equals 1/4. Okay? And all of these are going to, and since these are all the same probabilities for all the branches, they're all going to be 1/4 chance of coming up with those outcomes. Heads, heads, or heads, tails, or tails, heads, or tails, tails. All right? Let's show another example. In this example, our two events is spinning a spinner here, that's pictured here, and landing on orange, or spinning it and not landing on orange. And then it's the second event is rolling a die and having it land on 2 or less, or having it land on 3 or more. So our possible outcomes are we could have an orange, and then it's less than or equal to 2. We can have an orange, and it's greater than or equal to 3 on the roll. We could have not orange, any other color on the spinner, less than or equal to 2. And we can have not orange, and it could be greater than or equal to 3 on the roll. Those are our possible outcomes. So now let's look at the probabilities on the branches. So spin in orange is 1 out of 6. 1 out of 6. Not orange, the probability of that is, well, it's 5 spaces out of the 6. It's not going to be orange. Okay? Probability of rolling a 2 or less, well, that means you could roll a 1 or a 2. So that's 2 out of 6, which is 1/3. And then our probability of rolling a 3 or more is 3, 4, 5, 6. That's 4 out of 6, which is 2/3. Again, same probabilities down here, 1/3, 2/3. All right, so now to find the probability, the question might ask you, what's the probability that you spin orange and you roll 3 or more? Okay, so you spin orange and you roll 3 or more. So what we're following is this. We're going this branch and this branch. So then all we do is we multiply those probabilities. 1/6 multiplied by 2/3 equals 2/18, or 1 out of 9. Sorry about my handwriting here on the screen. All right, let's say they said, okay, what's probably you don't spin orange and it's 2 or less? Well, then you go this way, this branch, and then 2 or less. Okay, so then that's going to be 5/6 multiplied by 1/3, which gives you 5/18. So the probability would be 5/18 to get not orange and 2 or less. Hope this helps. Thanks for watching.